Alright, so today I'm going to be explaining this important paper with the title Equivariant Graph Attention Networks for Molecular Property Prediction. This paper in 2022. Learning and reasoning about 3D molecular structures with varying size is an emerging and important challenge in machine learning and especially in drug discovery. Equivariant graph neural networks can simultaneously leverage the geometric and relational detail of the problem domain and are known to learn expressive representations through the propagation of information between nodes, leveraging higher-order representations to faithfully express the geometry of the data, such as directionality in their intermediate layers. So we propose an equivariant GNN that operates with Cartesian coordinates to incorporate directionality, and we implement a novel attention mechanism acting as a content and spatial dependent filter when propagating information between nodes. Our feature representation can be expressed as a tuple of a scalar vector. So S is invariant and V is equivariant. That transforms accordingly when a group action is applied on them. The symmetry considered in this paper is SO3 group of orthogonal matrices with determinant 1. The group action here reveals that the scalar component is not affected by the rotation, as this is not a geometric quantity and therefore invariant. The vector feature, however, transforms as an order first tensor and is therefore rotated. So standard message passing neural networks implement a message and update function for feature representation. Now we aim to implement the message and update function, this message and update function, to be equivariant to satisfy the property of 6. The traditional transformer models has revolutionized the field of NLP. The self-attention module, which lies in the core of transformers initially designed to operate on sequence of tokens in NLP, consists in essence of two components: input dependent attention weights between any two elements of the set, and an embedding for each element called value. Since graphs are naturally represented as sets with underlying structure through the sparse connectivity between vertices, the implementation of self-attention was introduced by GATS. This is an overview of EQ-GAT encoder architecture. Here in B you see the update layer, and in C is the message function. And finally in D we have feature attention calculation that inputs SO3 invariant representation and outputs a content as well as spatial based filter. So we initially embed atoms of small molecules or proteins based on their nuclear charge Z. As nuclear charges are discrete and bounded, we utilize a trainable embedding lookup table, which we commonly use in NLP. About distance encoding, interatomic distances are embedded using the Bessel radial function that serve as distance encoding into the attention mechanism. And for feature attention, given invariant scalar embeddings, we use two linear layers to obtain query and key embeddings. Then we proceed to embed a content and a spatial dependent anisotropic embedding through element-wise product. Finally, we have value transforms. Value tensors are computed using weighted matrices. The invariant feature retention depends on content-related as well as spatial-based information and act as a filter. So in case that no initial vectors such as velocity or forces are available, equivariant representations in the point cloud can be constructed as a function of position. Formally, equivariant features are obtained and hidden equivariant type 1 embeddings are filtered using scalar multiplication. The rationale for including the cross product of two transform vector features is to enable interaction between type 1 features and is inspired by TFN, which models tensor product between the two type 1 vector, resulting in a rank 2 tensor. Such a rank 2 tensor includes antisymmetric elements presented in the cross product. We combine the two equivariant representation into a final aggregated equivariant message passing. The aggregated message passing embedding is obtained in the same fashion, and we follow this vector space terminology and write MI as the final aggregated message embedding. Then we have update the hidden embedding for each target node by adding aggregated message M sub I. So they did experiments on this QM9 dataset. These are mean absolute errors of different properties that are predicted.